We're going to look at something called a double integral. A double integral is basically an integral inside of another integral. And the way we compute a double integral is by essentially doing the inside integral first, getting an answer to that, and whatever answer we get, we then integrate that, doing the outside integral. So first we'll take the antiderivative of e to the x minus y. Notice we're integrating with respect to y, which means at this moment we're assuming that x is held constant. Assuming that x is a constant, the antiderivative of e to the x minus y is negative e to the x minus y. You could use a substitution for that. U equals x minus y would work fine. Then we input the limits of integration, which in this case are 3x and 0. Plugging both of those in for y gives us this, which simplifies to this with a little bit of algebra. And now essentially we've performed the inner integral of this double integral. We now proceed to the second phase of the problem, where we integrate that with respect to x, the outer variable. Doing the integral gives us this. You could do a u substitution on the first term if you wanted to check that out. I used u equals negative 2x to integrate the first term. And then plug in the limits of integration, 1 and negative 1, and subtract as usual. This is quite messy, but simplifies a little bit down to this. And we've now computed this first double integral. Here we're being asked another double integral, only instead of the differentials dx and dy, we have a d capital A. dA stands for d area, and it has to do with the physical manifestation of double integrals, which we're not getting into here. But suffice it to say, when you have a dA and some region R, where that region is defined by the x and y constraints on the right, you can essentially turn this into an integral within an integral. I usually do my y integral on the inside, usually doesn't matter. And now, as usual, we have to compute the inside integral first. Thinking of x as a constant and y as our variable, this integral works out to this. You may want to pause and analyze that. And now that we've done that, we can substitute our limits of integration in for y as 1 and negative 1 and subtract as usual. Before I do my second integral, it may help to clean up the inside of this integral first. So doing a little bit of algebra on the inside leads to 2x squared, and now I can integrate that from 0 to 3. Doing the usual process, substituting the limits of integration and subtracting, ultimately, work not shown here, yields 18.